Welcome to Module 20 on point slope form. Make sure you have your notebook out, ready to take notes. Don't forget these notes can be used on your quizzes and tests, so it's in your best interest to write these things down for yourself. All right, new page in your notebook. You're going to want to write down Module 20, which is on point slope form. Essentially, what we're going to be working on today is writing an equation when you are given a point and the slope, or when you're given 2 points. Notice that we don't see anything about a y-intercept, which is why we need a new type of equation to help us, because we won't always have a y-intercept available to us. So there's a couple of ways to do this, and we're going to start off using our typical slope-intercept form. So I want you to write a new topic, writing equations given the slope and a point. And I want you to remember that when we learned about slope-intercept form, we learned that it was y equals mx plus b. M stood for your slope, B stood for the y-intercept, and the x and the y were the points on the line. There are an infinite number of those. So we can use that information to help us. You might want to write this stuff down now if you don't already have it. I am not being given the y-intercept here. What I'm being given is a point and a slope. So if I try to use slope-intercept form, I have the slope, but I don't have the y-intercept. But I can use my point, my x, and my y to figure out what my y-intercept is. So the y is 2, x is 9, and I'm going to figure out what my y-intercept is. So my y-intercept is negative 16. That's not an equation though, so I have to go back. I have to remember that slope-intercept form requires a slope and a y-intercept. I now have my y-intercept and I have my slope, so I can substitute that in, so it becomes 2x minus 16. See if you can use that same method to do this problem on your own. All right, you should have started with your slope-intercept form. Y is 2, m is negative 3/2, x is negative 8, and we're going to find the y-intercept. Don't forget that when you multiply fractions, you can use canceling. 8 divided by 2 gives us 4. Now I'm left with negative 3 times negative 4, which is positive 12. You also can just plug that straight into your calculator. If you use your fraction button, you can do negative 3/2 times negative 8, and it will also give you 12. We're going to subtract 12 from each side, and so b equals negative 10. But this isn't an equation, it's a y-intercept. So we have a slope and we have a y-intercept. So I can substitute that in. So we get negative 3/2 x minus 10. That's one method to figuring out what your y-intercept is when you're given a slope and a point. But there's another method where you don't have to rewrite your equation at the end. So I want you to write a new topic, Introduction to Point Slope Form. You don't have to write this whole sentence here, but you definitely need to write this. And let's make sure we understand what these subscripts are. They are not exponents. Those are talking about specific points. And notice there is no y-intercept here. What we have in our equation is m, which stands for slope. We have x1 and y1, which is a specific point on the line that you're being given from the problem. And the other x and y are all the other infinite points on the line. Those are what stay in your equation. So make sure you have point slope form written down before we move on. So let's talk about writing an equation in point slope form. And remember, new topic, writing an equation in point slope form. All right, so sometimes mathematicians aren't very creative. Slope-intercept form needs a slope and a y-intercept. Point-slope form needs a point and a slope. Point-slope form is the same pattern every time. Y minus y1 equals m times x minus x1. The nice thing is you don't have to memorize it. As long as you're taking good notes, you should have it in front of you. So your negative 9 is your m, your point is your x1 and your y1. There is no y-intercept, which is why they're asking us for point-slope form. The y always stays. The y1 comes from the specific point from the problem. The m is negative 9. It comes from your slope. The parentheses always stay. The x always stays. The x1 comes from there. This is fine. You also can clean this up. Remember, we can do keep, change, change, so this becomes x plus 1. Either one of these answers would have been fine. You pause the video, see if you can try this one on your own. I'm going to give you some fill in the blanks to do, and you see if you can fill those in. Go ahead and do that now. So this should have become y minus -9 because this is your x1 and this is your y1. Your slope is 5/2 and your x1 is -6. You can leave it like that, or you can do keep change change, so it becomes y plus 9 equals 5/2 times x plus 6. Either one of these answers are correct. The biggest mistake people make is they forget that this first blank is your y because it's your second number. If you label these at the beginning, that will help you keep track of those in your mind. All right, so you've got a new topic here, graphing a line given an equation in point-slope form. So what we've got here is an equation in point-slope form because it's y minus some y value equals the slope times x minus some x value. Now there's two ways to go about this. One is you can just look at this and figure out what point the line is supposed to go through, and then you can use it to graph. So for example, I know right away that my slope is 4, but the point is a little bit more challenging because of the minuses. We do not have a y point value of -1. The y1 is just 1. So this is something comma 1. Same deal here. This should be minus, which means it's the opposite of whatever this is, so it's -3. So when I graph, it's -3, comma 1, and I should go up 4 and over 1, up 4 and over 1, and then I'm out of room here. If I wanted to go the other way, I could go down 4 and to the left 1. Now the alternative way to do it is to rewrite this equation in slope-intercept form. So you can distribute, so y minus 1 equals 4x plus 12, and then add 1 to each side, so y equals 4x plus 13. The problem with that is there is no spot for a y-intercept of 13 because our graph is too small. So this first method can be a way to do that when you can't find your y-intercept, or maybe it's a fraction or a decimal and you can't fit it on your graph in some way. All right, I want you to try this one on your own. See if you can just start by just finding your slope and the point, and then we'll check it together. So you go ahead and fill in those blanks now, and then we'll do the graphing together. All right, you should have identified a slope of 1/2. These are already minuses as they should be, so I just want the opposite of those. The x value is the opposite of a -3, which is a +3. The y value is the opposite of a -1, which is a +1. So I can use that to graph 1, 2, 3, up 1. And then my slope is up 1 over 2, up 1 over 2, up 1 over 2. Now, what if we tried this the other way? What if we distribute our slope? So we have y minus 1 equals 1/2 x minus 3/2. And then we have to add 1 to each side. So y equals 1/2 x. Let's see, what I've got is -3/2 plus 1. That's -3/2 plus 2 over 2. So that's -1/2. So the y-intercept should be -1/2. So my line's a little off here because it's crooked. This is a good example of why this method doesn't always work and why it's important that you're able to just identify the slope and the point. It's much easier to do because y-intercept of a fraction makes it harder to graph. All right, you pause the video, see if you can identify your slope and see if you can identify the point. Go ahead and do that now. Your slope here should have been -1/5. The point should have been the opposite of these, so instead of a -2, this is a +2, and instead of a +4, that's a -4. This is a perfect example of one where you might not want to distribute because this is not going to come out evenly and it's going to make it harder to graph. So we go to the right 2 and down 4. And there's our starting point from here. And then my slope says to go down 1 and to the right, 1, 2, 3, 4, 5. Down 1 and to the right, oop, we're out of room. So instead I could go up 1 and to the left, 1, 2, 3, 4, 5. Up 1 and to the left, 1, 2, 3, 4, 5. And there's my line. Again, I know my line's a little crooked, but this y-intercept would be a fractional amount. So that's why it's much easier to do it this way. Now, point slope form can also be convenient for writing the equation of the line through two given points. So again, when I write an equation, I either need a slope, a y-intercept, and for that, I would use slope-intercept form. Or if I had a point and a slope, for that I could use point-slope form. Be a minus. Might want to write these down if you need some review. In either case, I need the slope. It doesn't matter what type of equation you're writing, you have to have a slope for a linear equation, and I don't have one. So my first step here is to go back to what we learned about slope. We can find slope by doing y2 minus y1 over x2 minus x1. Remember, this is just your first point. This is just your second point. That's what those 1s and 2s mean. So this is 5 minus negative 3 all over 4 minus negative 6. Keep, change, that becomes 8. Keep, change, that becomes 10. So I'm left with 4/5. That's not an equation, that's just our slope. So what we have is our slope, and we have some points. So I'm going to use point-slope form to write my equation. It doesn't matter which of these points you use. They're both points on the same line, so we can use either one. It will end up giving us the same equation. So I'm going to use this second one since it has fewer negatives. So it's going to be y minus 5 equals the slope times x minus the x, which is 4. Turn it into slope-intercept form, I'm going to distribute. So y minus 5 equals 4/5 x minus 16 over 5, because 4 times 4 is 16, and that's an indivisible 1. 5 times 1 is 5. Now we just add 5 to each side, so it becomes y equals 4/5 x. You can either use your calculator or you can go over to the side. I'm doing negative 16/5 plus 5 over 1. I need a common denominator of 5, so that's negative 16/5 plus 25. Negative 16 plus 29 is negative 5, so that's negative 9/5. You also can just use your calculator to get your fractional answer for that, especially when you're working on your final exam or your quizzes. You pause the video and just start by seeing if you can find your slope. Go ahead and do that now. All right, you should have subtracted your y's on the top, 1 minus 5, and your x's on the bottom, 2 minus negative 4. 1 minus 5 is negative 4. 2 minus negative 4 becomes 6. 4 and 6 are both divisible by 2, so that's negative 2/3. All right, you pause the video now. See if you can substitute into your point slope form. I'll leave you some blanks here. You go ahead and do that now. All right, I'm going to use this point. So that should be y minus 1 equals negative 2/3 times x minus 2. Now to turn this into slope-intercept form, we want to distribute. So we have y minus 1 equals negative 2/3 x. A negative times a negative is a positive. 2 times 2 is 4, and so that becomes 4/3. Now we just need to add 1 to each side. So this becomes y equals negative 2/3 x. I'm trying to add 4/3 and 1. I need a common denominator of 3. This becomes 3, and if I add these, that just becomes 7/3. Again, you can use your calculator and your fraction button. If you need some help, ask your teacher to show you where your fraction button is on your calculator during office hours. You can also do this with a graph, especially when you can't identify your y-intercept. I have no idea what that y-intercept is. It's like 1.7 or something, which would literally just be a guess. So instead, what I can do is use my slope, which I don't need to calculate because I can just do rise and run. There's my slope. I'm going up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. So my slope is 6 over 4, which reduces to 3/2. And then you can use either one of these points. It doesn't matter which one. I think I'll use this one, 1, 3, to write my equation. So it becomes y minus 3 equals 3/2 times x minus 1. And then you can distribute. So it's y minus 3 equals 3/2 x minus 3/2. We're going to add 3 to each side. So y equals 3/2 x. And I'm trying to do negative 3/2 plus 3 over 1. I need a common denominator of 2. So I multiplied 1 times 2, so I'll multiply 3 times 2, so this becomes 3 halves. You pause the video and see if you can do this one on your own. Again, this is a good reason to use point slope form because I cannot find my slope, my y-intercept. It's not a whole number. Go ahead and try this now. All right, you should have started by finding your slope. You could calculate it if you want using the 2 points, but I'm going to use the graph. The rise is 1, 2, 3, 4, 5, 6, and I went down. The run is 1, 2, 3, 4, and I went to the right, so it's positive. The rise over the run would be negative 6 over 4, which reduces to negative 3 halves. And then you can use either one of these equations. I think I'll use the point 3 comma negative 1 as my x1 and my y1. So this could become y minus negative 1 equals negative 3 halves times x minus 3. Keep change, so this is y plus 1. I'm going to distribute. Negative 3 halves times x is just negative 3 halves x. Negative 3 halves times negative 3 is positive 9 halves. I'm going to subtract 1 from each side, so y equals negative 3 halves x. And then I'm doing 9 halves minus 1, which is 1 over 1. I need a common denominator of 2. So this becomes 7 halves, which is why I wasn't able to find the y-intercept because it's not a whole number. And you're done. This video will be available on Haiku if you need to rewatch, and will be available on each skill for Module 20 in ALEKS. Make sure you do your practice problems in ALEKS by selecting Continue My Path. Once you do your practice problems, don't forget there's an explanation for each type. And I think the explanations are pretty good for this module if you want to take a look at those. When you're all done with the practice, you're going to go to assignments and you're going to take quiz 20. Have a great day.